Multiple choice question 4. Which of the following statements must be true? If two events are independent, they must be disjoint. If two events are dependent, they must be disjoint. If two events are disjoint, they must be independent. If two events are not disjoint, they must be independent. If two events are disjoint, they must be dependent. Whew. All right, let's think about what independent means. If A and B are independent events, then the knowledge of the outcome of one event doesn't give me any additional information about the probability of the other event occurring. So for an example, suppose if event A is students who have brown hair and event B is students who like bowling. Then if I randomly select a student and I tell you that the student has brown hair, does that give you any additional information on whether or not the person likes to bowl? So we have two independent events. So we've decided that having brown hair and liking to bowl are independent of each other. Now we ask ourselves the question, must they be disjoint? Since it's possible, well, disjoint means has nothing in common. Since it's possible for a person to have both brown hair and like bowling, knowing that the two events are independent doesn't necessarily follow that they must be disjoint, because a person with brown hair could like to bowl. Dependent events. Okay, so let's give ourselves an example of two events that are not independent. So people with red hair are more likely to be Irish. So if I know someone has red hair, that changes the probability of them being Irish than just randomly selecting somebody from the general population. But just because someone has red hair, they could also be Irish, meaning not disjoint, so they could have red hair and be Irish, but they don't have to be Irish. So again, disjoint events. If two events are disjoint, they have no outcomes in common, and the probability of both A and B occurring is 0. So if they have nothing in common, the probability that they both occur is 0. Again, it's good to have an example to think about. If event A is students who are underclassmen at GA, and event B is students who are upperclassmen at GA, if I randomly select a student from the GA upper school and tell you that the individual is an upperclassman, does that give you any additional information as to whether or not he or she is an upperclassman? Okay, so if we know that they're an underclassman, they can't possibly be an upperclassman, since those two events can't happen simultaneously. They're disjoint. So if two events are disjoint, then they are not independent. Okay, so let's look at what we have. So if two events are independent, they must be disjoint. Well, we know that we could have events that are independent, like brown hair and liking to bowl, and they don't have to be disjoint. Somebody could have brown hair and also like to bowl. Or two events are dependent, must they be disjoint? So we said having red hair and being Irish aren't independent, since Irish people are more likely to have red hair, but they don't have to be disjoint. You could have people that have red hair and are Irish, and people that have red hair and are not Irish. If two events are disjoint, they must be independent. So let's go back and look at our example. If two events are disjoint, so we said being an underclassman at GA and being an upperclassman are disjoint. So they have nothing in common. They have nothing in common. If we know the outcome of one, then we automatically know the outcome of the other. So if two events are disjoint, they must be independent. That's not true. So if two events are disjoint, so letter E, if two events are disjoint, then they must be dependent. So letter E is our answer.